We will do for 2011 Math 21 Test 2, number 3. 15 cards are number 4 through 18. Now remember they told us 15 cards. 4 through 18 means 4, 5, 6 all the way to 18. The cards are shuffled and 3 cards are drawn and arranged in a row. Find the probability that all 3 cards are even. Now, even and odd. How many even numbers? How many odd numbers? Out of these 15 cards, 8 of them even, I think, and 7 of them odd. Okay, 7 of them odd. Now, to have 3 cards even, then I will have 8 permutes 3 over 15 permutes 3. Okay? Now, that's because the order is important, right? If we compute these using calculator, A permute 3, that's 336 over 15 15 permutes 3, that's 2730. If I divide 336 divided by 2730, I get, if I make it into decimals, I get 0.12308. That's the probability. Okay, the probability that all 3 are even. Now, but if we think about this, because all 3 cards are even, you can think of that as if, imagine if the order is not important. Okay, the situation that all 3 cards are even, maybe think about this. To have all 3 cards are even, regardless the order, right? The order doesn't matter. So if you can actually do it this way, probability that 3 cards are even, in this case, can be done by 8 choose 3 over 15 choose 3. Okay. Now, then if you use calculator, let me show you this time. If I use calculator, 8 choose 3, that's 56 over 15 choose 3. $455. Now then 56 over 455 will give me the same number. I hope you can see that. I get that number there, right? Which is the same to the number we get there, 0.12308 if we round it to 8 decimal places. Okay. Now here, even though they say that the order is important, but once all 3 cards are even, doesn't matter which even cards come first. All 3 of them will be even anyway. Now, part B. Find the probability that the first one is odd, and then followed by even and even. Now this will be, let's see. Let's do it one by one first. What is the probability that the first one is even? Is odd. There are 7 odd cards, so the probability that the first one is odd is 7 over 15 times, then the probability that the second one is even will be 8 over, not 15 anymore, 14, because one card's already taken earlier. And then the last card to be even will be 7 over 13. Okay, now if you think about this, let me compute that first. This is 7 times 8 times 7, that is 392 divided by 15 times 14 times 13, which is 2730. And if I make it into decimal, 392 divided by 2730, that will be 0.14359. That's the probability. Now, if we think about this, you can do it this way. This should be 7 permute 1. That's the number of ways for you to get an odd, and then times 8 permutes 2. That's the number of ways to get even after the first odd, divided by 15 permutes 3. Okay, and if you use calculator, you expect to see the same result compared to the first one. Now, of course, if you ask me which way, Thomas, you prefer to use, I still think the first one is easier to come up with. Okay, not that much hassle. The second method to do it tend to be it takes more maturity, and to come up with that answer takes more time maybe. Okay, but of course it would be nice if you know that. Part C, what is the probability that one of them is odd? Notice that when they say one of them is odd, the order doesn't matter. At least one odd. No, this is not at least one odd. One of them is odd. I'm sorry, the probability. So this is not at least. This is basically one odd, which means the other two are even. Okay. Now notice that this probability here is different from that one. This one, yes, you have one odd and two even, but the order is important. The first one has to be odd, and then the last two are even. Okay? Here, doesn't matter the odd numbers is the first place or the second place or the third place. Now then, in this case, we can use combination. Okay, out of 8 even cards, I will need to choose 2 of them, and out of the 7 odd cards, I will choose 1 of them, divided by 15 choose 2. That's the 15 choose 3. I mean, that's the total number of ways to have to choose 3 cards. Now, on the top, 8 choose 2 will be 28. 7 choose 1 is 7, and then 15 choose 3. I don't know. We need to use calculator for that. Let me put it here. So how to manage this? 15 choose 3. It's 455. Oh, I have it there. I have it there. I can just steal it from there. 455. So if I want to make it decimal, that will be 28 times 7 divided by 455. That is 0.43077. Okay, now part D, all 3 cards are at most 10. At most 10 means is either 4, 5, 6, 7, 8, 9, 10. How many are there? 1, 2, 3, 4, 5, 6, 7. There are 7 of them. Now all these 3 cards has to be among these. In other words, you have 7 cards which is less than 10. You choose 3 of them, and of those greater than 10, you choose nothing over 15 choose 3. Now notice that the order doesn't matter again, right? It doesn't matter which one comes first as long as it is at most 10. Okay, now 7 choose 3. Let's see what is 7 choose 3. That's 35 over 455. Yeah, I steal it again from there, right? That's equals to 0.07692. Okay, that's the probability that at 3 all at most 10, like that. Okay, now that's for, this is for fall 2011 math 21 test 2 number 3.